So here's our first question here, 3.2. I have two questions ready for this this video. So we're going to go through this one and then the next one. It's two questions which I think is actually really nice questions. So let's do this. We are asked to determine the value of, okay, so let's first read this, right? We have two triangles are given, right? And here it says where angle CAB is equal to PRQ, which is equal to 21 degrees. Angle ABC is equal to 105 degrees. Angle QPR is equal to 54 degrees. Angle ACB is equal to X and angle PQR is equal to Y. So that's the information we are given. So there's nothing too hectic. They're just telling us what's on the triangle. So it's not really important to look at that right now. They just say what angles are in the triangle just to verify. Okay, so what are we going to do here? We need to determine the values of X and Y. So check it out over here. Let's first determine the value of X. How are we going to determine the value of X? As you can see, okay, we kind of have an integration of just normal triangle geometry, but this is all just triangle geometry at this point, but it's mainly like similarity and congruency type questions. Okay, so let's look at this, right? We have the angle X here, and we can see that we have a triangle ABC. We are given two other angles, but angle X needs to be found. But we know that a triangle, all the angles have to add up to 180 degrees, so we can actually do this. And I'm just going to do the shortcut over here. X is equal to 180 degrees minus all the angles that we know. Because I'm taking everything over already. I'm just skipping a step. You're allowed to do this. The only thing you need, you don't even need like the workout for this, but I have to do the working out to show you how I get the answer. All you need to have is the correct reason and the answer. That's all you need for these types of questions. So it's 180 degrees minus 105 degrees minus 21 degrees. And the reason that we used over here is going to be, it's going to be the sum of angles in a triangle. That's our reason that we used. And then if we solve for X, we're going to get X is equal to 180 degrees minus 105 degrees minus 21 degrees, which is going to be equal to 54 degrees. So therefore, our angle X is going to be 54 degrees. Okay, now our next step is to find Y. How are we going to find Y? We're going to look at the triangle that includes Y, which is over here, and Y is there. And you can see it's the exact same thing. So we're going to do the following. We're going to say that Y is going to be equal to 180 degrees minus all the angles that are given. So it's going to be 54 degrees minus 21 degrees. And here we're going to have the same reason. I'm just going to copy and paste it like this. And then there. Cool. So it's the same reason that we used for the last triangle, and then we have the value of Y is going to be equal to 105 degrees. Okay, great. So now that we have this information, we can move on to the next question over here. And what I'm going to be doing, right, is I'm going to be keeping the X and Y values for the next question. So 3.2.2 says, hence, show that triangle ABC is no, not equal. It's similar. As you can see from the symbol over here, it's three vertical lines, so that means it's similar. Is similar to triangle PQR. Whenever they say hence, as you can see the word hence over here, hence just means with the information that you know. Or therefore, show that. Because remember, in the last question, we were asked to determine the values of X and Y. And because now we know the actual values of X and Y, now we can actually show that the triangles are similar. And that is what hence means, with the information that we know. Okay, now let's check it out. We're first going to be writing in triangle ABC. Remember the sequence that we've learned over the past videos, or in the similarity and congruency videos, we actually state which the step 1 is to state which triangles we're working in, and PQR. That is not P, this is P. PQ and R, colon. Okay, now we're going to show over here, our first one is going to be, remember what I said over here? We use this method over here, which is going to be AB over PQ. Remember the first 2 letters of the first triangle over the first 2 letters of the second triangle. So it's going to look like this. AB over PQ. And the reason why this actually works is because these two triangles are said to be similar. Remember that? But we are trying to show that they are similar. Remember, we're actually using the information that we have to prove that they are similar. And therefore, we can actually use this, this method. It's always allowed to be used, and we will get the correct answers. So AB over PQ is equal to, and then we can say AB over PQ is equal to, AB is equal to, oh, you know what I just realized? We're not working with sides, my fault. So actually we're working with angles. I did make a little mistake over there, but it's fine. So angle A, we're going to compare angle A. So in this case, yeah, that is the funny part over here. We're going to compare angle A with the angle that is exactly the same as angle A. So as in the diagram over here, we can see that the 21 degrees is the same as where R is equal to 21 degrees as well. So we can see from the diagram that A is equal to angle R. Angle A is equal to angle R, which is equal to 21 degrees. And then our reason is that it was given. Okay. Now our next one we're going to be looking at is the next angle. Note how we're actually going to be working in with all the angles over here. So our final answer is going to be angle, angle, angle. Our final reason. Now, as you can see, let's look at the next one. Let's look at B, right? We're going to compare the angle B with another angle. What is angle B equal to? Angle B is equal to 105 degrees. What other angle is 105 degrees? As you can see, where we worked out, y is equal to 105 degrees. So this angle here, Q, where y is equal to 105 degrees, Q is the same as angle B. Angle Q is the same as angle B. So therefore angle B is equal to angle Q. It's going to be equal to 105 degrees. 105 degrees. See, I almost made that huge mistake there. I was working with the sides because I'm so used to all of the questions with the sides. I've gotten so much questions like that in the exams, in the exam past papers. Okay, and then this, what you can actually say, and to sound cool, you know, you want to be like, oh, I proved all of this. I was the one who showed that x is equal to this and y is equal to this. You can say given, but it's not necessarily given to us that y is equal to 105. We can actually say the word proven, because we proved that y is equal to 105 degrees by using the interior angles of a triangle, or the sum of the angles in a triangle. Oh, sorry, I meant to say proven. So we can sound cool by saying proven over here. So we did the step 1 over here and step 2 for angle B. Now the last one we're going to be comparing over here is angle C. What is angle C equal to? Okay, so angle C over here, where is angle C? We can clearly see angle C is x. And what is x equal to? X is equal to 54 degrees. So we need to look for 54 degrees on the other triangle. And that's there over there, angle P. So therefore angle C is equal to angle P, which is equal to 54 degrees. And the reason is that we proved it. Remember how we also proved that proved the value of x? Now we can say we have proven this. And there's our third step there. Then now, because we proved all of the angles are equal for the corresponding triangles, we can say therefore triangle ABC is going to be similar to triangle, remember the order is also important, PQR, in that order. And then the reason we used was angle, 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 because note how we worked with only angles. That is the reason that we used. Okay, nothing too bad about that question. Let's move on to the last question that we have. So I found this question and I thought it was a very, very amazing question. I really like this question. So the question says the diagram below shows two triangles that are similar. Triangle YBA is similar to triangle YVH. So this is something new actually. We can see over here that these two they give us that these two triangles are similar, which they don't normally do. They normally ask us to show that they're similar, but this time they actually give it to us. But what is the catch? We can now see that they want us to, with this information, solve for x. Our favorite part of algebra is to solve for x over here. Okay, and they give us a hint over here that you can break into two separate triangles. So what do they mean by that? We can see that we have two triangles actually. If we split them up, we can see we have triangle YBA, and then we also have triangle YVH, this entire big triangle over here. So we have two triangles over here. So let us actually split them up. Let's see what it looks like split up. Let me just skip forward to that. So I've split these two triangles up, as you can see. So let's actually complete the information that we have, right? We can see over here that they give us lengths, and the lengths that I'm grabbing this thing. The lengths that they give us is YB is equal to 16. So let's write that down. We have it equal to 16 over here, YB. And then we have YA is equal to 17. So this one is just going to be equal to 17. Okay, what other information do they give us? For the next triangle, they say that YH is going to be equal to X. So we have YH right over here. And then our last one, which is YV. Well, we can see over here, here is YV, right? This entire side is YV. But the only thing that we can see is we have two numbers. And this, remember, one of those numbers are not the entire size of YV. But as you can see, if you add these two numbers together, 16 and 22, we'll actually get the real length of YV. So if we say 16 plus 22, we're going to get an answer of 38. And there, now we have our sides. And then for these sides over here, they didn't give us any of these sides, but what we can say over here are that those sides are proportional to each other. Why are we saying that? Because they actually told us that the two triangles are similar to each other. Okay, so what we are going to do, we're just going to represent those sides as its letters, its normal letters. So how do we start? So where do we start with the solve for x type of questions? Now, just hear me out over here. We remember in the normal type of questions where we show that the triangles are similar, what we normally do is we conclude at the end that the two triangles are similar. But because we have this information, we actually need to state that these two triangles are similar already, because they gave us that information. So we say over here that triangle YBA, this handwriting is so bad, honestly. Triangle YBA, okay, that looks better. Triangle YBA is similar to triangle YVH. YVH. That looks like a check mark. YVH. Okay, you know what? I'm just going to make do. And now, remember, okay, so let's look at this, right? What are we looking at? What we are looking at over here is going to be, we are going to be comparing the sides. Because remember, whenever we're dealing with similar triangles, we're either going to be talking about the corresponding angles are in proportion, corresponding sides are in proportion, or we are going to be talking about the angles are all equal. But as you can see from this information from the triangles, we are actually trying to show that the corresponding sides are similar or are proportional. But we already know that actually, because remember, these two triangles are proportional to each other, or they are similar. So therefore, we can say over here for our reason that sides are in proportion. So we'll just say prop. It looks like it's in proportional, but it's actually in proportion. So corresponding sides are in proportion. That is our reason over there. Now what do we do next? Now this is probably the part where you'll get stuck at. But as you can remember the rule that I told you, if we know that they are technically similar, but in this case we do know they are similar, so we can use this rule. We can say that this side over here is equal to this side of the second triangle. Or sorry, not equal, is a ratio of that other triangle. But we're going to do it in fraction form. So if you can remember that rule that we used, we're going to say over here that YB over YV is a ratio and equal to. Okay, if we can remember from similarity as well, when we are proving, we are actually, when we're also using corresponding sides in proportion, and that's why this reason is important, we know that all of the ratios are going to be exactly the same. So therefore we can actually make all of these equal to each other. So what do we do here? We can see that we can actually take the next two sides, which is BA over VH. We can write it as BA over VH. And this is also equal to the first and the last letters of both triangles. So this and YA is going to be all over YH. So it will look like this. YA over YH. And now we actually have a reason. Oh, I see. Okay. Over here, this reason is actually going to be here, right? And I hope that you're actually still watching this at this point, because obviously this is important that you pick up that I do make these mistakes. And these mistakes have been made before, I know that. But what we are actually supposed to write over here is that it was given to us. I just got them mixed up over here. Remember that they told us that these are similar. So therefore they gave us this information that those two triangles are similar. And then the reason for this, these equal ratios, is corresponding sides are in proportion. We use that reason in order to actually determine this exact statement over there. Now what do we do from this point? What we need to do is just plug in the values. So we see that YB is going to be equal to, YB is equal to 16 over here. And then YV is equal to 38. So we say 16 over 38 over here. So 16 over 38 is going to be equal to BA. What is BA? We can see over here that we don't even know BA. And we don't even know VH either, because BA over VH. So we just leave it as the normal letters, because we don't know the information there. So we're going to have BA all over VH is equal to, then we have YA. YA is actually equal to 17, and YH is equal to X. So we can do that. 17 over X. So it's going to be 17 over X. Okay, now what do we do from this point? Because BA over here is useless and we don't even know the values, we can actually just, we don't even have to use this. But we can see that because all of these ratios are equal to each other, we know that this ratio is also just going to be equal to this ratio over here. So we can actually just use that information there. And we can do the following. We can actually write them down here now. We can say that 16 over 38 is going to be equal to 17 over X. And then from this point, we can actually solve for X from this point. We can cross multiply, and then we get the following over here. If we cross multiply, we're going to get 16 times X, which is just 16X. And then we're going to have equal to 38 multiplied by 17, which is just equal to 646. If I'm not mistaken, from the calculations. Okay, and now we just have to divide both sides by 16 to solve for the X, to get X on its own. So these two can cancel out over here. And then we will have the final answer that where X is going to be equal to 646 over 16. If we put that on the calculator, it's going to be equal to 40, 375. So we're going to get 40, 375. Okay. And that is our answer for x. We can stop here at this point. So it's not really that bad when you have this type of question. You just need to, the first step you normally have to do is just to break up the two triangles to actually make it easier to interpret the information. Then we need to obviously show what we are given. We are given that these two triangles are similar, and now the next part we can use is that because these two triangles are similar, we can actually use the reason corresponding sides in proportion, because remember we are working with only sides in these triangles because we are given sides and we need to find a missing side as well, and it's similarity, so that is why. So that reason actually makes this statement over here true. So now from that point we can just plug in our values that we have, and because we don't know what BA over VH is, we don't know any of those values over there, we can just ignore that and we can actually just work with the two ratios that we actually know the values for. And then from that point over here we can just cross multiply, and then from that point we just solve for x, and then we get the final answer of x is equal to 40, 375.